Hi guys, in this video I'm going to be working through a radioactive decay problem. Before we get going, I just want you to understand that, this is with our bank account problem stuff. And as you look at this formula here, it says a 30-gram sample of radioactive iodine decays in such a way that the mass remaining after T days, which by the way, that's big because that tells us that T is measured in days. That's going to be our unit later on, okay? Not years like our bank account problems. And this time it specifically says T is in days. And it's given by this formula where m of t, the mass of time t, is measured in grams. After how many days are there only 10 grams remaining? Okay? I want you to understand that this is the same formula as A equals PE to the RT. Look at that. Except in this time, instead, E is right there, R is up here, and T is here, okay? This time, instead of going through and talking about money, we're going to talk about the mass of this substance as it decays away, okay? So the 30 is the starting amount, a 30-gram sample. That's the starting amount. E means it decays continuously. The interest rate, or in this case, the rate of decay would be 9.3%. It's negative because it's going down, okay? We're going to lose mass as time goes by. So it's a negative growth rate. And T is the time, and this time it's in days as they state, specifically because they've stated it. So after how many days, that means we're solving for T. Is there only 10 grams remaining? So that would be my final amount. If it was money, I would call that A. Here I'm going to call it M of T, right? So let's put in some values here. Ready? 10 is my final amount, is equal to 30, which is my starting amount, times E to the negative 0.093 times T. My first step in every problem is to divide by the principal, by the starting amount, right? So I'm going to start off by dividing both sides by 30. So I get 1/3 on the left, and I get E to the negative 0.093 T on the right. Just like my continuously compounded interest problems, to get rid of E, I have to LN both sides. LN and E are opposites. So that gets rid of this stuff. I'm left with negative 0.093 T, just the exponent on the right. The left-hand side is the natural log of 1/3. So on my calculator, what I'm going to do, by the way, last step then, I'm going to find out what this value is right here, and then I'm going to divide it by the negative 0.093 T, right? Because right now it's negative 0.093 times T. Opposite of multiplication is division. So on my calculator, here we go. Natural log of 1/3 is that value right there. I'm going to divide it by negative 0.093. And T is equal to 11.8. And in my units, they told us T is measured in days. 11.8 days later on. So hopefully that makes sense. That's a radioactive decay problem. It's not too bad as long as you understand it's still A equals PE to the RT. We're just calling it something else. We're dealing with something that's not money.